So what are dictionaries? So dictionaries are a data type with key value pairs. So there is a key and a value associated with it. The keys must be unique and it is unordered, so there is no indexing, but it's not completely indexed. So you can, instead of the number indexing numbers, you can use the key values or the keys to access the value pairs. And it's mutable in the sense you can remove key values and you can add key value pairs. So coming on, let's take an example. So let's take a dictionary called flavor, which is equal to, we write it in curly braces similar to set, and the key value pairs are the existing in this. So let's give a key name called chocolate. Is the value will be dark, comma, ice cream. So this chocolate right here is a key, and after the colon, this right here is a value. So you can even have number as a value, or even the key can be a number, comma 3:5. So this is our dictionary, and let's move on to calling this one. So how you call this is type in the dictionary name, square brackets, and type in chocolate. You should have the print statement always. So if you're not doing it in Jupyter, so it gives you dark. That is the value. And if you have 3 right here, you get 5. And if I give ice cream, I get 1. But is this possible? Indexing is not possible. And also using this value or this value, you can't get the key value. So it doesn't work vice versa. Dark doesn't work. Only the key values can be called. Now let's start with the get function. The get function is used similar to this itself, but it has a difference. So what we do with the get function is I give flavor dot get, it gives you dark. But if I give something like C, it doesn't give you anything. But does it give an error? No, it doesn't give you an error. But if I give here C, it gives you a key error. But in the get, it doesn't give you an error. If assigned to a variable also, so it's going to be a none type. But if this has a chocolate and now it's a string because this is going to return something. If it's not returning anything, it will return none. And since chocolate is a key in here, it will return this right here will return dark, which is assigned to A. So that's how the get function works. Dot keys, dot values are used to print only the keys and only the values. So how will you print it out? Flavor dot keys. See, it gives you all the keys: chocolate, ice cream, and 3. These are the key values. So let's print it out. So this is the key value, dictionary keys. And then if you give dot values, flavor dot values. It gives you all the values. Coming on the items. So items give you both the key and the values. So flavor dot items give you both chocolate, dark, ice cream 135. And as you can see, it's written in a tuple enclosed within a dictionary. So is this something we can do? If you call lists of flavor dot items, you can even do it for keys and values. You get this right here. So if I assign this to a variable and I print a of 0, I get the first one. And if I just want the word called dark, give 1 again, and see, we have a dark. The same list of function can also be used for keys and values. So dot values. It gives you a list of all the values. So that's the use of dot keys and dot values, and they can be converted to a list or tuple. And shall we convert it to a tuple? Tuple of flavor dot keys. It's a tuple. So we are done with these. Let's move on to the next one. We have seen n for almost all the data types discussed so far, even not n. So let's check for with a small example because this key and values. So let's see if chocolate in flavor. So what about dark? False. Why did it give you false? Values won't be taken into consideration in inclusion. So word in and not in, it gives you true, but if I give 3, 3 here is an integer. As we have seen here, this 3 is to 5 is an integer. So it gives you false because it's not an operator. 3 in true flavor, so it's true because 3 is a key inside. So inclusion and exclusion works for the key values, key pairs, not for the value pairs. That must be noted. And as it's written in the definitions also, if the specified key is existing in the dictionary or if the specified key is not existing in the dictionary. Coming to length. Length of flavor. This doesn't take key and value separately. Instead, one key value pair is counted as 1. So we had chocolate, ice cream, and 3. So the length is 3. So coming on to enumerate, enumerate gives you the index and the key value here, not the value pair, but instead the key value. Let's take an example, enumerate of flavor. So this is showing you the memory address, which we do not need. So let's convert it to a list, tuple, etc. This gives you 0. And at the 0th index, there is the key called chocolate. At the first index, it's ice cream. At the second index, it's the number 3. That is what the enumerate function does. This is really helpful for the for loops. So we'll see it there. Now, iterating requires you to have knowledge about for loops. So we will have this also done during after learning about for loops and if conditions. So we'll do it there. Don't worry. So coming on to removing key and value pairs, we have four ways. So the first method is using the del function. So we can use this to remove a key value pair or the dictionary itself. So let's take our dictionary flavor and remove it. Now, if we search for dictionary flavor, it's not defined. So it's deleted. So we will have to make a new dictionary. Let's take fruit is equal to apple, which is red, orange, which will be number. So this is our new dictionary. Let's print it. So this is the new dictionary, and you can even check type of the dictionary, which is a class called dictionary. But it also should be noted that even this gives you this. And by the way, this is same for everything. Even if you check type of a string, it's going to give you a class string when you print it, but just type of S will give you string. It's similar to a list, class list. What about a tuple? Is this how you define a tuple? A single tuple has a comma. So these are clauses, and if you print it, this will be the output. So that's an interesting case we came through right now. And let's go on with the deleting of apple, deleting a key value pair. So del of fruit dot, not a dot, open square brackets and apple. Now fruit won't have apple because it's deleted. Coming on to pop, and let's take these two together because they are similar but with some differences. So we need another list, or let's take a num list, which can be big. 1 is to 2, 3 is to 4, 4 is to 5 is to 6, 7 is to 8. So now we can give num list dot pop this num list. If you don't give any arguments inside, it will give you an error because it needs one argument. So here we'll have to give a key value. Or if you give 2, it's not a key, it's a value. So if you give 1, it's going to pop and it will return you that value. So if you can even assign it. So if you pop again, 1 doesn't exist because 1 was previously popped. So if I give 3 right here, and I can even assign this to a new variable and print it out. Okay, it's calling the pop again. So let's run it in a new cell. So you get this value, not this, but the value, not the key value, but the value's value. And coming to pop item, this also returns you pop item, but it doesn't take an argument. Let's type numList dot pop item, doesn't take an argument, but it removes it from the last. And print B, you get 7, 8. As you can see, it has taken both the key and also the value pair into a tuple. Let's see the type, which is a tuple. And coming on to another example for this is if I type A is equal to num list dot pop 0. Does 0 exist? No. But you will get some error like this if you run this statement. So what you can do is you can give a fallback value. So not existing. So what is a not existing? And you don't get an error. So if this key is not available in the dictionary, it's going to assign this to the variable. Or let's just do this and it returns. So that's the difference between the pop function and the pop item function. Let's go to the clear. So what clear does is basically it empties the whole dictionary. So let's type our num list. I guess it still has one. So that's the num list dot clear. And we have an empty dictionary. So all the keys and the values are removed. We are done with this and welcome to a new set of dictionary operations. And let's get started with the first one. So coming to updating or adding a new key value, we have to take a new dictionary here. Let's take vehicle, which is equal to car. Let's give it Tesla. And then if you print the vehicle, this is our dictionary. But I don't want the car to be Tesla. I want it to be something like a BMW. So type the dictionary name in square brackets, give the key name, and assign it to the new value. If you print vehicle again, you get car as BMW. But what if I give your bike and type here Enfield? Bike doesn't exist, but if I run it and run this again, the key is added in. So that is how you add a new key with new value. Coming on to union or update. So we can update this dictionary with a set of other key value pairs. So we'll take vehicle dot update with curly braces apple no ship well plain 3345 and print vehicle. Is a spelling mistake, yes. So our ship and plane were added to this dictionary. So it mostly works like union. So it's going to combine this. And what if we have bike here again with Enfield? Okay, there is an error here. My bad. Okay, let's put it like that. And if I print it like this, it's still going to be Enfield. But what if I change it to bike is 45? Value of bike is updated. Just like you update this, if you give update and put a new value for an existing key, this gets updated. That's what it does. So isn't that a little inconvenient sometimes? Because if you're not sure, if you think in a big dictionary, something like bike is already existing, and if it's existing, you don't want to add this value. You want it to remain Enfield itself. That's when you use set default. So what setDefault does is we'll take vehicle dot set defaults and let's take a key which is bike and another will give 3 4 will give NV. No, let's give a number. So it will be something different. 0.5. So if you run this, it gives you 45. But if I even run the vehicle, bike is 45. So what does set default do? If the key is existing already in the dictionary, it will return you that key's value. But if it's not existing, it's going to assign a new key with this name and the value of that key would be this. So let's give bike 1. And as you have seen, it returns this value. You can also assign it to something. And here A has this value. But if you look into this, since bike 1 is a new value, it is given a new key and a new value. So that is the use of set default, which separates it from update. Now we are done with set default. We have seen the get function before. Let's do a quick recall. What does vehicle.get bike do? It returns you the value for the specified key. Even if you give something that doesn't exist, it doesn't give you an error. But if you need a fallback value, like we have given for the pop function before, right here, not existing, we can also give key not found. Yeah. So now it's going to give you this error instead of, it's not an error, it's going to give you this fallback value if the key doesn't exist. So that's how you use get with fallback. And we are done with that. And now coming to a new set. So copy is something we have learned, but shall we do a quick recall? So let's get started with something called the copy function. As I've said, vehicle is this big dictionary. If I give A is equal to vehicle, and I print A, delete A of car. Print A, no, wait, it's running even the delete again. So I'll run it in a new place. So the car and its value is gone. And even in our vehicle, the car and its value is gone. So to avoid that, we give dot copy and we assign it B and delete B of bike. And what does B give? B doesn't have bike, but our vehicle right here has bike. So that is the importance of the copy function. I'm so sorry about the video. The phone just got disconnected, so the video wasn't broadcasted to my PC. So the video was off for the last 2 slides, I guess. So my bad. But now it's all proper since I've noticed the problem. So let's start with merge dictionary. So what does merge dictionary do? It helps you combine two dictionaries into a single. So for this, I would like to take a unique case. Let's take A and B, two dictionaries. A will have X, 1, Y as 3. Now here, we will have y as 2, and okay, let's take 20, and z, we'll keep it 2, I guess. Z as 4. And so we have, my bad, Z must be a string. So we have two dictionaries here. And how do you merge them? You use this. If you give A merged with B, you get Y as 2. But if I give B merged with A, you get Y as 3. And also know the order. It's going to be Y, Z, X, and XYZ. So it first takes this dictionary and any similar values, it will take it from the second one. So that's why Y here is 2. And coming to this one, Y here it is 3. So whichever dictionary comes here, any common element, it will be this dictionary's element, this dictionary's value that will come in the output. So that is a difference to be noted. And while ordering, this dictionary elements first, then this dictionary elements. If there are common elements, they will just be updated. So that is about merging dictionary. And from keys is used to create many key values with a similar value pair. So let's create a new dictionary using from keys. New is equal to from keys. We'll have to specify the dictionary keyword. This is DRCT. It's not a keyword, it's the dictionary function. So dict dot from keys, we give it in a list. You can have the list here, or the list here in the sense just give 1, 2, 3, 4, 5, or have it in here and with a name. List 1 is equal to A, B, C. And then we specify here list 1 with comma. We need, if you give no second parameter, you get none for all the value pairs. If you give something there instead, that value will be the value for all the keys. You can even check the value as A gives 0. So this is a common value. You can even have a string here. So that's how you use from keys. Coming on to the sorted function. So sorted gives you a new sorted list. It's not going to give you a dictionary, but it will be a sorted list. Since dictionary is unordered, so sorting a dictionary won't do you any good. So sorted will give you a list. So let us make a new dictionary for this with Z is 3, comma, A is 5, comma, B is 2. So what it does is it's going to sort based on the key values only, not the value pairs when you specify sorting of just the dictionary. So give the list a variable name, sorted A, and if you print B, it only has these key values, not the value pairs, and they are in alphabetical order. But if they are numbers, the numbers will be sorted. You can also do something like A dot, we have seen what does dot values give. They give you the values. So if you sort it using this, all the values get sorted. We can also give keys and you get 1, 2, 3. That is similar to doing this. And another interesting thing is items. We have seen it gives you a tuple of both. So now it gives you a tuple and the tuple is sort. So what is the basis of this sort? It's going to be the key value pairs because it can't be sorting based on this because two same key value pairs cannot exist and hence no two tuples with same key value pairs exist. So the sorting will be based on the key values. Now, what if there is a letter here? Does sorted work? No, because it needs to be of the same data type as we have seen before also. And also note that if all the key values are suppose say strings, all are strings, then this thing works. If this is A and this can be B, it works like this. And if I give values also, it works. And even keys will work because all the key value pairs need to be the same. So that is another interesting thing to be noted right there. And just give A also, and it sorts only your keys. So we are done with the sorted and format map. So this is similar to our strings format. Okay, it's the formatting format. So in strings, we learned how to use dot format with args and quarks. Let's take an example. Print name is this dot format Bob. Name is Bob. You can even give a name parameter. This is a named parameter or quark. So name is Bob. So what is a format map? This means you can use a dictionary instead of writing it here. So for example, let's take a dictionary D, which has name as Bob and age is 32, 34. Fine. And here we give name. It's a named parameter, so it should contain the name and age, which must be in curly braces, years old. This comes with dot format underscore map of the dictionary name. Our brackets must be closed properly. And you get name is Bob and 34 years old. So that's how you use the dictionary directly for printing it. If you don't give anything, it gives you error because it should be named. So this name comes here. Can you even repeat it? Yes. So repetition of this value and this value. I even give here age, it works. In dot format, we give name as it is, like name is equal to Bob. But here, even though the dictionary has these quotes, we are still giving name. Giving quotation marks for this will give you error. So just give this as it is. Don't specify the quotation marks. That is one thing to be inferred or noted from this. and we are done with format maps. So, which is similar to format and it uses dictionary. Coming on to the last three topics. I guess this is repeated right here. My bad. So this is not there. And this, as we know, comprehension is part of for looping and if conditions, etc., which we are going to do next. So this will be taken after for loops. So the only thing left in this dictionary topic is nested. So shall we start with nested dictionaries? So how do you think nested dictionaries can be made? We can only give a key and a value pair. Let's take the same dictionary. So name can have first name, last name. So for another dictionary inside, just give curly braces for the value and first underscore name is Bob and last underscore name is Bob Marty. Bob Marty. Fine. And there are no errors, so this is a good code. And if you print this, you get it like this. But how do I get this? Giving this gives you this list. So if I want Marty, I take another square bracket with the last name, which gives you Marty. So this is how you go through a nested dictionary, and this is how you make a next nested dictionary. This you can further nest this by just doing this one nested two, and our new dictionary is here. Bob last name gives you a dictionary, but I want one. Remember, this is not indexing. This is not an index value, but this is a key value. So you get to, that's how we deal with nested dictionaries.